Okay, so we're now going to look at some examples using our shear and dilation and combinations of those, and rotations and reflections as well. Okay, so this first example, which you've got in the notes, we've got the composite transformation T, which is a result of, first of all, a dilation of factor 2 parallel to the x-axis with a dilation of factor 5 parallel to the y-axis. That sort of as a combination together is then followed by a shear parallel to the x-axis of factor 4, and then thirdly followed by a dilation of factor -6 parallel to the y-axis. So you'll notice here I've labelled them A, B and C, and that's just to give us names for our matrices which we'll write. Okay, so first of all let's consider the dilation both parallel to the x-axis and y-axis here, which forms our transformation A. So you remember that transformations parallel to the x-axis, or specifically dilations, is A 0, 0, 1, and parallel to the y-axis is 1, 0, 0, A. So that's on your information sheet. So we can combine them together, and that's what we've done here for A. The transformation A, the parallel to the x-axis is a factor 2, and parallel to the y-axis is a factor 5. So we can put them both together. So this combination together of these two matrices is what we can do when we've just got a dilation in both directions. We can put them in one, and that's what we've done there. Okay. For B, okay, we've got a shear parallel to the x-axis, and on your information sheet that's given as 1A 0, 1. So that's a shear parallel to the x-axis, and in this case it's a factor 4. So we've got a 4 there in place of the A. And then for C, we've got a dilation of factor -6 parallel to the y-axis. So here we are using this one again. So C will be 1, 0, 0, -6. And what we're looking at is a combination of all three of those. Now, composite transformations, let's just go back here to these little notes here, which we didn't cover in the previous video. If we have a linear transformation A that's applied to a point or a curve and is followed by a linear transformation B, then the composite transformation is BA. Okay, even though A has come first, followed by B, we write the composite transformation as BA. The order is important, okay, and there's a few different ways it can be written. BA like that, or BOA, it's a little O, or a little O down as just like a subscript. Okay, just different ways of representing the same thing. Okay, so what we're doing is we've got A followed by B followed by C. So in terms of what we do with the matrices is that we multiply them together, but in the reverse order of what's been done. Okay, so we're going to go C, we write C first, 1, 0, 0, -6. And then we follow that by B, 1, 4, 0, 1. And then we write our transformation A, 2, 0, 0, 5. And we need to multiply those together. Okay, we can do, as long as we write that down here, we can then put that into our calculator and multiply them together. And when we do, we get 2, 20, 0, and -30. Now sometimes you'll be given a question where you're given information like that and you're asked just to write down the transformation. Okay, it's important that you don't just leave your answer as a matrix. Okay, you need to write your transformation. So T, that's the label given here in the question. Find the composite transformation T. Okay, so that's exactly what we're doing. Our first part of this question is to write the composite transformation. So t as a transformation, changing any point x, y into here. So this is 2 times x plus 20 y. 0x, we don't worry about that, so we just write minus 30 y. Okay, this is our transformation that the question's asking for. Okay, so don't leave your answer as a matrix, put your answer as a transformation. Okay, so that's part A. Let's then look at part B. Find the image of the point 48 under T. Okay, so under that transformation T, find the image of point 48. So you'll remember that to write an image, to find the image, we're multiplying any point, any original point, x, y, multiplying it by the transformation t to obtain our image point, x dash, y dash. Okay, so it just happens that our point is 4, 8. We multiply that by our transformation 2, 20, 0, negative 30, and we multiply that through. 2 4s are 8, plus 20 times 8, which is 160, so that's 168. And our y, 0 4s are 0, plus negative 30 times 8, that's negative 240. Okay, so this is our image point. So we make a just little statement, okay, as written here. Okay, under T, the image of 48 is 168, negative 240. Alright, so that's part B. Part C, find the image of the curve under T. Yes, the curve x squared y equals 1. So that's the curve that we've been given. X squared y equals 1. And we are going to find the image of that curve under that transformation. So you'll remember t times our original point is x prime y prime. That means that x prime x y, our original, will be equal to the inverse of the transformation t multiplied by x prime and y prime. And this is the process we go through when we are trying to find the image curve. Okay, so the inverse transformation matrix, we're just taking our 2, 20, 0, negative 30, that's our transformation matrix T. We can put that into our calculator, raising it to negative 1, so to find the inverse, and we get half, 1/3, 0, and negative 1/30. So that's our inverse transformation matrix. So applying that to this equation here, xy equals our inverse transformation matrix times x prime y prime. That gives us our x coordinates. Our original x coordinate, okay, is equal to 1/2 times x prime plus 1/3 times y prime. Okay, and that's what we've got here. And similarly for y, y is equal to negative 1/30 times y prime. Now if our original x value is given by this equation, which involves our image points, we can substitute those into the original equation, and we know that it will satisfy the original equation. But because they have our image coordinates, when we rearrange that, the result is, on simplifying it, we obtain the image curve. And that's what we're doing here. We're substituting x for this expression. Okay, so we've got to put that in there and then square it. substituting our expression for y in there, and we're going to expand. Okay, upon expansion and multiplying through, you can see, just take each step. First of all, when we expand that, we get this result. And then the next step is we've multiplied by the 30, okay, which is why the 1, or by negative 30 in fact, which is why the 1 becomes negative 30. This is still unchanged in here. Okay, now there is the lowest common multiple, or the lowest common denominator amongst these three numbers here is 36. So multiplying both sides by 36, we end up with negative 30 times 36 on the right hand side, and on the left hand side that 36 will cancel, and we'll cancel with the denominators, leaving these numerators 9, 12 and 4. Okay, and then collecting everything over to the left hand side, we obtain this expression. Okay, it's a good thing we don't need to graph it. Okay, but nevertheless that is the image under T. Okay, so just work through these sorts of problems. Don't be thrown off by their complexity. Just work it through algebraically in a correct way. Okay, sometimes it's clear what it is, and sometimes it's not. Okay. We'll stop there on that video, but we'll do the next video, which involves this example here.